everyone. Welcome to our first lesson in Algebra 2, where we are covering Chapter 1, Section 2, Algebraic expressions and sets of numbers. Let's go over a couple definitions real quick. First thing we want to talk about is a variable. What is a variable? Well, a variable is a letter or any kind of symbol that we use to represent any number. It doesn't have to be one specific number. It could be any and all numbers of a certain type within a certain set, or any of the numbers that we have in mathematics. The second thing we want to talk about is an algebraic expression. We use these a lot. The algebraic expression is just the combination of numbers and variables connected by mathematical operations, such as addition, subtraction, multiplication, division, exponents, and roots. We also have some other operations, including logarithms, trigonometric functions, and various others. Algebraic expressions often occur in real-world scenarios, which is why we use them. Okay? And so a lot of what we'll be doing is using algebraic expressions to model scenarios and use those to answer questions as they may relate. So we'll start by evaluating some algebraic expressions in a real-world scenario. So we have this chart over here about driving costs for different types of cars. We have a sedan, an SUV, and a half-ton truck. So what we want to do is we want to consider the expression 0.582m, where m represents the number of miles driven. And that's very important. We need to understand what our variable is representing. So given the chart to the right displaying the driving cost, what could the expression represent? So we have to think about it. Well, what does 0.582 represent? Well, we know that m represents miles, but what we don't know right off without any more context is what 0.852 represents. So we want to look at our chart and see if we have that value anywhere, and we know that it is listed here at 0.582 underneath the sedan. By looking at and identifying that this value or this dollar amount is related to the sedan, and we look in this category label and it says cost per mile. Well, that makes sense that the 0.582 represents the cost and m represents our miles. And so we can use that to explain what this expression is. Given that 0.582 represents cost and m represents miles, we clearly see that the expression represents the cost per mile for driving a sedan that is medium in size. A medium-sized sedan, that is our average cost of driving when we're driving 15,000 miles per year. So we can look and say, okay, well, what is the cost of driving a sedan for 15,000 miles? So what we're doing is we're given a value for m. If m represents miles and they tell us how many miles, then we can go ahead and actually use this to evaluate the algebraic expression. So our algebraic expression 0.528, we're going to substitute 15,000 miles in for the variable of m. We're going to substitute that in, and now we can actually evaluate. When we have a coefficient and a variable next to each other, that operation is multiplication. So we'll multiply those two values together. We will go ahead and multiply, and we get a product of $8,730. So the cost of driving a sedan 15,000 miles is 8,730 miles. Let's look at another problem. Here we're given a formula. Tiles used for edging in a bathroom are in the shape of a triangle. The area of a triangle with base b, so they've told us what one of the variables represents, and height h, again, that's another variable, is a equals 1/2 base times height. So we're given a formula, and we're told that it represents the area of a triangle, where b represents the base and h represents the height. So we can use this formula to find the area of a tile if the base measures 3.5 centimeters and the height measures 8 centimeters, we can go ahead and substitute those into our formula. So A equals 1/2. We'll substitute 3.5 for the base, and we'll substitute 8 for the height, and then we'll just multiply these all together. We will multiply, and we will get our area of 14 centimeters squared, because area is measured in centimeters squared. Next one is not a word problem, but it's a similar idea. We just have an expression. We want to evaluate 3x minus y when x equals 15 and when y equals 4. So we substitute in 3 times 15 for the x value minus 4 for the y value. So we'll go ahead and we'll do the multiplication first, giving us 45 minus 4, and then we'll finish with the subtraction to get 41.